Okay, this is a web track talk, so the slides are on the web. If you want to follow along on your own devices for, accessibility reasons or something, and then you don't have to take pictures all the time. All right. Hi. This is the UI and UX benefits and trade-offs of local-first apps. Hello. My name is Alex. I'm from a little company called Neighborhoody in Berlin, and this is our website. You can see the word offline is fairly prominently in the middle there. That's a big focus of our work. So we've been building offline-capable web apps for over a decade, and we use two databases called CouchDB and PouchDB to do this. Open source projects we're also heavily involved in. And in 2013, we popularized the concept of offline first as a way to build your apps, as a part of the thing called Hoodie.js. Hoodie was a library that allowed you to build offline-capable web apps. That means the apps were networked, but you could go offline anytime, and they would just continue working. And that was all powered by a sync engine. And sadly, Hoodie never really took off, but the term offline first did. So there was a list apart blog post that was pretty popular, and it went out into the world and became a thing. Now, the buzzword in the talk slides, talk title was local first, and I'm talking about offline first, so what's going on there? The thing is, offline first is where I come from. Local first is the newer thing that more people are familiar with. But yeah, there's related ideas, somewhat different goals. There's a lot of overlap. Focus is somewhat different, and I have no time to get into this. That will be a whole separate talk. The important part is that they often have the same technology at their core, and that is a sync engine. So I should have just called it that in retrospect. So hello. Let's talk about sync engines. Sync engines are an abstraction layer, and it manages the data storage on the client device as a real kind of partition database, and also the transmission of the data between the client and the server or other clients. So that means there is proper local data storage on the client. There is data network traffic between the local and the remote database, and the whole point is to keep the things in sync with each other through disconnections and all the other stuff. So why do people do this? Well, building apps this way has a bunch of very concrete benefits, and the most obvious user-facing benefit is performance. So if you have no network requests, you don't have any latency. It's always faster to read from the local device than to hop over a bunch of devices to US East 1 and all the way back again. And it doesn't matter how much money you throw at CDNs or regional data distribution. It's always going to be faster if you have it on the thing, right? And that alone is a great reason to build apps with sync engines, and a lot of people do it just for that reason. But you don't just get a benefit when the connection is slow, you also get a benefit when the connection is gone. So if you store data on your device, you can use it when you're offline. And maybe even more importantly, if the data store is on your device, you can create things while you're offline. And that unlocks a whole bunch of use cases you couldn't really cover with traditional architectures. And there's also a bunch of developer benefits that make this really quite delightful to work with. So you don't have to do any more network requests in your code. That's really cool. You don't have to handle retries and all sorts of other issues. You only have one pipeline for displaying things in your UI. It doesn't matter whether the current user made a change or some other user somewhere else. Once it arrives via the sync engine, it always goes through the same one single pipeline, so you're not doing things all over the place with the UI. You might get features like optimistic updates and real-time UI for free, because that's just how sync engines work, right? When you write to the local data store, it's immediately there to be displayed, even if it takes longer to get to the server. And if other people make changes, those changes just arrive on the client. You don't have to do anything to make that happen. You're probably going to need less infrastructure, because many user interactions never touch the server. They can be handled entirely on the client. And if your app still works when the client is offline, it also still works when the server is offline too. So this can take a lot of pressure off your team. So downtime isn't an immediate disaster that produces piles of support requests and bad PR and stuff like that. And there's been research that slowness actually causes more permanent abandonment of apps than downtime. So maybe that's a good shift of priorities. And also, prototyping is lovely. Like you can do everything in the browser. No server, no backend, no mocking, no dummy data. And then once you're ready, all you do is attach a database to it, and you're done. That's all very nice. Now, in case you've never seen what this looks like from a developer side, let me briefly show you how we do this at our company, and that will illustrate all of these benefits nicely, I think. So I'm going to show you a very simple sync engine. It's going to use PouchDB and CouchDB because that's what I know. These are companion databases, so Couch runs on a server, PouchDB runs in the browser, and they can talk to each other and sync data, which sounds useful for what we're doing, right? It's going to be local first. It's going to have a local data store. It's going to work offline. It's going to be real-time, reactive, have optimistic updates, and it's going to be just 10 lines of code. Vastly oversimplified code because it has to fit on a slide. You know what it's like. But yeah, let's look at those 10 lines of code. If we want a local database, we have to instantiate a local database. That's just make a new thing. It's not very exciting. Once we have that, we can do things with it, okay? Next thing, we make it real-timey. And this is where the similarities to many other sync engines come in. So many sync engines emit events whenever something changes in the local data store. And then you can react to those changes. So in PouchDB, it's called the changes feed. And in practice, in this listener, we would hook in our reactive UI. So something appears in the local database. We have to decide, is it relevant to what the current user is looking at? And if so, we put it in the right place, the right reactive variable or collection, and then the UI just updates. Now, this is all just local up to this point. So let's connect it to a remote database as well. As I said, Couch and Pouch are companions, and they can communicate via a replication protocol. So all we've got to do is turn it on. There's a sync method that turns on bidirectional replication, which means changes flow in both directions. We can say live true, so this stays open, keeps happening until we close it. And then retry true just tells it to retry the connection if it ever gets completely severed. And that's it. Now we can store data. And this is just putting a JSON object into that database. And since we've already started the replication in the line above, the new document is automatically going to be propagated to all other connected databases that want to have it, which is very convenient. And our UI will update automatically as well, because it's connected to the changes feed. And if we write something to the database, it'll go to the changes feed immediately, and we can render it. Now, of course, I'm glossing over a million things here, so there's no authentication or error handling. But that's already the bare bones of an offline-capable, real-time, reactive, collaborative to-do list. And because we're using a database that's explicitly built to be good at syncing, we get a lot of these syncing capabilities out of the box without having to build them ourselves. Now, remember the dev benefits we just listed? They're all nicely on display here, right? No more network requests. It's cool. No difference between local and remote changes because everything goes through the changes feed. Doesn't matter where it came from. You get optimistic updates for free because that's just how sync engines work. You get real-time UI where other changes come in and appear immediately for free because that's just how sync engines work. And yeah, this all works if you go offline, no problem, because you're never making any active network requests, and the replication protocol is totally capable of dealing with outages and resending data and stuff like that. It just handles everything for you. And it's easy to see how nice prototyping is with this, right? You can just do the whole thing in the browser. Now, the talk description said this was a zero marketing thing. I'm not trying to sell you anything, but I think Couch and Pouch are valuable enough tools to know about, so I'm going to spend 2 more slides on those. So these databases are built specifically to replicate data. Like they're partition tolerant, and that's what they do. So they also natively handle things like conflicts. So you can imagine if your participants are all offline or the network is partitioned and people change the same record in the database and then you sync that all together, you have a conflict, what do you do? So these are made to handle that. Now, people usually like to build syncing things nowadays with CRDTs. We'll talk about those more in a minute. Quite often, those libraries store operations instead of state, and then they compute the current state of whatever you want to look at. And you can't actually look at a document in the database. You always need the software layer on top to be able to access the things. And that's not the case in Catch and Pouch, which is something I personally really like, is that the data representation in the database maps very closely to what the data looks like in the UI. It's not a black box with lots of levels of abstraction on top. So the data is robust because it stores state, and the documents are complete. It's inspectable because it's all human readable and concise, and the data maps to your UI. So a to-do list item in the database looks pretty much like a to-do list item in the UI. It's portable because everything is JSON everywhere, and it's accessible. CouchDB is an HTTP server. So every piece of data and every function in the database is accessible via HTTP. And since basically everything speaks JSON and HTTP nowadays, it's really good future-proofing in a way because you're not tied to any libraries or technologies or stacks. Right, now as we briefly alluded to, one of the central problems of syncing data around between databases is that you're going to run into conflicts. So let's look at those for a minute. So sync engines, especially in offline-capable apps, appear to easily cause write conflicts. Right? It's very easy to visualize why this would be the case. And many people have the perception that traditional architectures don't have this problem, but that's not really true, right? They've been part of the web since the very beginning. And to illustrate this, let's say we have an old-school MySQL app with a single database, and two people are working on a page, right? Both of them have opened the same page, and they've thus fetched partial copies of the data, really. And these are now effectively disconnected from their original source. Like everyone is still online, but if a change happens in the server, Alice and Bob are not going to know about it. This isn't a true network partition in that sense, it's just stale reads. But the outcome is the same, and I think you all know what's coming now. Bob makes a change, the state in the database is changed, but that change never makes it to Alice. So when she makes a change, she brings the central database to the next state. And because the database has no concept of history or causality or anything, it will just apply whatever change it's given, right? It has no idea what the change was originally applied to. So Alice is right as 1. But really, there are no winners here, because as soon as Bob navigates somewhere, his changes are gone forever. And that also has a bunch of interesting observability issues and social problems, right? Now, what does Bob think of Alice now? And this has been and still is the default behavior in many stacks. And in this case, the conflict doesn't even really exist as an entity that you as a dev could do anything about. You can't even see it. The database eradicates the conflict the moment it happens because it doesn't know what conflicts are, right? It just applies write after write. So that behavior has always been around, and that behavior is called last write wins. And that has the obvious downside that it randomly destroys user data because last doesn't mean anything. The last write is in no way better or more true than the write before it, and no amount of vector clocks or whatever other timing technology you might throw at it is going to change that. It's not really a conflict resolution mechanism, it's just a way of moving on, and kind of sweeping the conflict under the rug, because you have to move on, you can't just wait. And it's probably caused everyone here, frustrations, you've had arguments about work disappearing. I'm sure all of you have caused this as well without ever knowing, because in a last right wins scenario, the last right never knows that they've destroyed some other user's data, right? It doesn't sound great, but at the same time, it still happens all the time and it's completely normal. And the majority of stacks works this way, but why? Well, the collisions are perceived as comparatively rare, and depending on your use case, that may be, right? If you have something like a message board where people post sequentially and only add to a shared data set, for example, you don't get conflicts very often. But as soon as people work on the same data sets, it happens. The other problem is that dealing with the whole thing is non-trivial and is usually more expensive than just offloading the problem onto the users. However, your reasons for building software with the sync engine may be incompatible with this, right? So you should know that most sync tooling uses last right wins in it somewhere. Most of them have it as like the last layer of defense before they give up completely. And that may be completely fine for you, right? It's fine for loads of software and businesses, and it's been the status quo for decades. But maybe your users' data is too important to do this, and you can't afford it, right? So you need to know, you need to be aware that this is a thing. Now, one of the great things about sync engines is that what we just saw, like this stale reads thing, becomes a lot less likely, because when you have a sync engine that continually updates all of the parties, there is less opportunity for data to go stale. The window of opportunity for conflicts is generally much smaller. That's another benefit. Although that brings with it some challenges, as we'll see in a bit. Now, before we get to the proper UI UX bits, I have 4 bits of general advice if you're thinking of doing this kind of thing. And the first one is, you don't need to use CRDTs. So they're kind of perceived as like the default technology for doing sync these days, and they're really not. There are loads of them about, it's hugely popular, but I've been doing this for 10 years and I've never used one. And I don't want to knock CRDTs, they absolutely have their use, but there are other ways of doing things that you should know. I also find the name somewhat unfortunate. It overpromises a bit. It just allows you to have conflicts in the first place, and most libraries then try to do automatic conflict resolution. But as we saw, that can only go so far. At some point, it no longer resolves conflicts, it just pretends they didn't happen. And CRDTs are cool because they bring conflict handling and sync to databases that can't natively do it, right? But if there are databases that natively do it, then you can also consider using those instead and save a bunch of effort. Anyway, second point, you can't sync everything everywhere. And that sounds obvious, but it's frequently forgotten. So client storage, client devices have less storage than servers, and more importantly, you don't control it. You can't scale it if it runs out. You probably don't even know that it runs out. You need to consciously choose what you sync where and when. And in my experience, there is no generic solution to do this. In every single project we've done, we've defined custom syncing behavior because the use cases were always so extremely specific, not just per app, but sometimes even per user role. And in this vein, data grows over time. Your snappy prototype can become completely unusable within just a few short weeks of real-world use because you didn't anticipate the various dimensions in which data can scale. And that's especially relevant if you can't reach that data because it's in someone's pocket, for example. And you must have an eviction plan for old data on client devices. You can't just keep filling it up, right? And all of this means that if you really want to build an offline app, you have to make sure that your business model actually can accommodate that. You will only have partial data in some cases. So e-commerce, for example, is a really bad candidate for sync engines. It just wouldn't provide any benefit, just problems. Third point, is your app going to have a central authority? Is it going to trust client rights, or is it going to do a bit of both? So if it's truly offline, you probably have to trust the client. If your clients are offline for weeks on end, you can't just pile up writes and then send them off to the server to have them validated and then rejected, and that's just going to cause a horrible mess. And that means at least some parts of your business logic must live on the client. And that can be an absolute no-go for business-to-consumer apps because you don't want to put the code that people are paying for onto their devices, right? But it's less of an issue with stuff where the users are members of the organization or employees of the organization. And you can totally do local first with limited or even no offline capability and a central source of truth. So the project management software Linear, for example, does a lot of really good local first stuff, and people are continually amazed how incredibly fast it is. They don't trust their clients. So all of the clients have a local first data store, they have a sync layer, but everything is approved by the server. And while this does work offline, they don't advertise it heavily. It's not a central feature. It's more of an enhancement, so the whole thing doesn't break if you go on a plane for a few hours, right? But it's not really meant to be used offline by loads of people simultaneously for long periods of time. And that's a totally valid approach. Their users are super happy. It does exactly what they want from them. So they've picked exactly the right bits of this technology for their needs. And frequently, you just have to do both. Even if you trust client rights, you can't have your client send emails, for example. You still need the server for that. And last general point, collaboration versus offline capability. So many sync libraries advertise that they can do real-time collaboration and offline. And that's often true, but they can't do it at the same time and well. And that's totally not their fault. That's just the nature of the problem, right? The more collaborative your app is, which means the more people collaborate on the same items of data, the less offline it can be. These two things exist on a spectrum. The further you go in one direction, the worse the other side gets. The problem is that trying to do both at the same time is very likely to cause loads of conflicts that you then have to deal with. So what can we put on this spectrum as examples? Let's use games. If you still know what Minesweeper is, it's a quintessential single-player app. You can get the app, be offline for months, play it, no problem. But you can even do things like have a global high score list, for example, with every player in the world on it, because players don't truly interact on the same pieces of data there. They just add their high score to a shared data store, which means this is write once, update never, which is always a good principle, because if you only ever add things and never edit them, you're very unlikely to get conflicts. On the opposite end, you'd have something massively multiplayer like Fortnite, where it doesn't work without the other player's immediate input. It's just pointless to play it offline, really. You'd probably die of boredom or something. And Google Docs, interestingly, is not a game, but sometimes it is effectively a real-time multiplayer game, taking place in a single shared space. But that's actually a pretty rare case for a web app. So what would be exactly in the middle? Well, to belabor the metaphor a bit, let's say chess by mail. So the players are mutating a shared state, and they're syncing their changes, but they're doing so one after the other. They can only move their own pieces, and they can't go back in time to change things. So again, it's write once, update never. And the use case has some very specific properties that allow it to live nicely in the middle. So it depends. Anyway, finding out where you are on the spectrum, where your use case is, or rather where you want to be, is a really central part of figuring out how everything's going to work for you. All right, the meaty bits. Practical UI and UX advice. So what's the problem? A lot of the patterns in syncing apps are really unfamiliar to people, right? It's just not the way the web works for most people, and a conflict is not a failure mode people are familiar with. So the goal is to provide guidance through this unfamiliar territory, to not overburden users with new technical concepts, and just generally try to surprise people as little as possible. Because people are part of the system, right? The design should match the user's experience, expectations, and mental models. But that's kind of tricky if our architecture by its very nature does the opposite, right? If nobody knows these things, it's hard. But we can at least try. So, challenges. One big drawback of real-time UIs with a sync engine is that the UI continually updates. And I know that a couple of minutes ago I said that was a benefit. And it is, but it's a double-edged sword. It can be really tricky to do well. So let's look at a real-world example of what can go wrong. So another example from Linear is, so this is a project management app, and it can have statuses that you can edit and change, and then you can apply those statuses to your tickets. And Thomas Artmann from Linear used this example in a talk and said, if one user deletes one of these, it gets deleted for everyone who's currently looking at that board. And he describes this as awesome. And yeah, technically this is super nifty, right? But in practice, it's really irritating. You were just about to click on the thing, and then suddenly it's gone. It's a weird user experience. So instead of deleting and doing something super abrupt, consider disabling the thing. And if it's a really important piece of data that was deleted or changed, then maybe add a toast. Like if it's impactful and affects a lot of things or people, then maybe those people should know about it, right? Another example, you can even cause confusion by updating data that nobody currently cares about just because UIs have side effects. So consider this backlog here with 2 tickets. You're about to delete ticket 2, and then the sync engine syncs in another ticket. And where does it go? Of course, it goes in the top of the column, and it bumps down the other tickets, because that's how CSS works, right? And that has nothing to do with your sync engine. That's a bit of a rug pull, really. So this ticket insertion should probably be gradual and not instantaneous, so it's not such a surprise again. So consider carefully what kinds of updates can happen in your UI, right? So the data in the UI can change while you're looking at it. We just saw that. It can also change while you're not looking at it. And while that's kind of the regular way apps work, right? You navigate somewhere, and in the meantime, something might have changed. Usually that follows an action by the user, a navigation or clicking something, right? We're not really that used to stuff just happening off to the side somewhere. And the data in the UI, sadly, can also change while you're changing it. That's really the painful one. This is similar to the examples we had earlier, but at least this time you can catch the conflict and help the people deal with it. But, I hear some of you think, but Google Docs is extremely real-time, and that's no problem. Yeah, because it depends on the context and what you're doing. It's subject to the same real-time dynamics, but there are concrete details that make it work. So there is a strong sense of it being a singular shared space, a document, where everyone has a presence, the avatar, and a location, the cursor. So this aligns well how humans see the real world. If we collide in the real world, we don't blame the laws of physics, right? We blame ourselves or each other. And in the same way, if we produce word salad by typing over each other in Google Docs, that's obviously our fault, right? The other cursor was right there. What was I thinking? That's one of the reasons why this works, because it maps to a real-world analog. And also keep in mind, Google Docs effectively communicates every single keystroke to everyone. That isn't an easily transferable technical solution that fits a lot of other use cases. So what to do? I know these events all seem rare, but they can really add up and become grating. If you can, show users where everyone else is. If you can, split people into different spaces so fewer of them can collide with each other. If your app is extremely online, you can consider locking UI elements when people are doing things with them. But be aware that locking things is really trivial, but unlocking things has loads of edge cases and can get really complicated. It may not be worth the trouble. Make your data and your UIs granular. Many small things, not few big things. Try to avoid big writes. And also, animations to draw attention to changes and to make them gradual. Be aware that the changes might occur where somebody isn't looking, but also be aware that some changes are important enough to just nag everyone about them. If you can, have history of changes where people can just read up on what happened. Might be interesting. And be aware that people will still be able to cause conflicts. You're not out of the woods yet. Now, real-time UIs have another interesting aspect, rolling back optimistic updates. So if you don't trust the clients and you need the server to approve everything, you might be in the situation where a change happens on the client, gets displayed instantly, cool, goes to the server rejects it at some point, the rejection comes back to the client, and the UI reverts. That is really surprising. Something your user just did has disappeared. That's a bad user experience. So really the worst thing you can do is just that. That's like last write wins all over again. You've built a frustration factory. So alert users to the fact that the change could not be made, and maybe why, maybe it's important. Help them navigate back to where they were, but also keep in mind they may not want to do this right now. And show them what their unapplied change was. And if your changes are small, as they should be, this gets easier, because then you can just deal with this in a message or a toast or something. You don't have to invent a new UI element to deal with it. And if this happens too often, everything falls apart, kind of, then you have more fundamental problems with your architecture that don't fit on this slide. So, in summary, it's not a multiplayer game. There are no well-established patterns or real-world analogs for this kind of thing. So don't surprise anyone. Apply changes gradually. Realize that some things are more important than others and may deserve more attention. Changes can have side effects that have nothing to do with the sync layer. And if you can, keep a history. It's always nice to be able to see what actually happened. Remember the selective syncing thing where you can't have all data on every device? That is quite unintuitive for people, because they're on the web, right? They can always have everything whenever they want to, except in a local first app, that's not true. So your UI has to be able to deal with data being missing. So either it's completely missing because the client is offline, or it's briefly missing because you only have part of it and you have to get more. And in both cases, this is different than what you're used to building. It takes a bit of extra effort to deal with it. But you can make it less grating if you consider stuff like prefetching. So if the user intent is reasonably clear, somebody's hovering over a link, you should be able to figure out what data you need and then get that before they click it. Now, having your code deal with this is one thing, having the user deal with it is another, because sometimes they need to know, right? Communicating this is weird because people aren't used to it. You can do stuff like messages. You know, I'm currently offline. I'm showing you local data only. Click here to find out more about how this app syncs. And that's not great. And also remember that being online is not the same as being able to talk to your server. So if you do this kind of thing, the sync engines usually help you with that, figuring out whether you can talk to the server. That's more relevant. But to make it even more awkward, if a client is offline, that raises a couple of questions. Like, is the local data complete? No idea. No way to find out. Is the local data up to date? No idea and no way to find out. The only way to find out would be to talk to a server, and I can't do that. This is a weird thing to expose to the user. But often the only way to communicate is to explicitly say it somehow, like here in the corner. But try not to expose the inner workings of the app or introduce new words or concepts. It's the focus on the time span that makes this message useful. It communicates the severity of the disconnection without you, as the developer, having to interpret it. The user knows best what kind of thing might have happened in the past 3 hours, in this case, and they can judge what that means. To make it a bit easier, I would advise to make sync state a constant topic, but don't call it that, right? Don't bring it up when it becomes a problem. Normalize the topic and accustom people to it. Always have it around, even if everything is fine, like in the corner there. And yeah, just always leave it there. Avoid technical terms or negative language. Like, this is nobody's fault. Nobody made a mistake. Nothing's broken. It's just normal. That's how the internet works. And leave the interpretation of the severity to the user by providing the time span. And this is what people do. Like, on my way here, this is the Deutsche Bahn app. On the top left, it says updated just now. On the top right, it says updated 3 hours ago. And this is perfect, right? It has a fixed place in the UI. It's always there. It doesn't use any technical terms, and it's focused mainly on the time. And I can make the judgment of how severe that is, right? Should I be doing something? Is it really important for me to get a connection or something? So limited availability of data is a bit unintuitive for people, but limited availability of features is a bit more well known. Users already know that features may be missing depending on context. You know, what plan do I have? What permissions do I have? What is my role? Stuff might be disabled, and you can use that. Maybe if they're offline, they can just read stuff. Right? And then you can use disabled buttons. A well-known UI element, and most people are fine with stuff being disabled if they can figure out what the reason is, right? Likewise, you can use drafts. That's another transferable concept. Your users maybe can't do the actual thing right now, but they can draft the thing, and you can keep it around in like a conflict-free, user-specific limbo to deal with later. And yeah, I'm going to run over slightly. Last one, conflicts. You're not going to get around them. You're going to have to resolve them at some point. They confuse the hell out of people. It's a failure mode people are not accustomed to. Also, you can't resolve all conflicts automatically. At some point, you have to decide, am I going to bother the users with it so they can resolve it, or am I going to lose some of their data? Both cause disruption, and while manual conflict resolution saves the data, it requires extra user interface. Not great. So maybe try avoid causing them in the first place. I already mentioned, keep your data small. Lowers the probability of conflicts. Some use cases are really good for writing data once and then never updating those records again, like ledgers, logs, stuff like that. Try and be non-destructive. Don't ever let users really delete things. So CouchDB does this internally, for example. It never deletes anything. It just marks items as deleted and keeps them around because that breaks fewer things. And you can use that pattern on different levels in your app. Maybe don't let offline users change existing things because that causes conflicts. They can create stuff, they can read stuff, it's fine. And if you do let them change stuff, maybe only their own data. You know, lean on the concept of the human as a singleton that isn't capable of causing conflicts with itself. Only do automatic conflict resolution where it's logically feasible, right? So I'm going to hurry up a bit now. A three-way merge, for example, is a legitimate way of doing this because it retains all inputs. Nothing gets lost or deleted. And many CRDTs do this. If you do last write wins, make a conscious decision. Is this okay for you? And 100% automatic conflict resolution isn't a useful design goal, and it can cause more harm than good. But if you do decide to let humans resolve conflicts for you, try to reframe conflicts with familiar terms from other realms, right? So provide a conflict resolution UI that doesn't look like one, because nobody wants to deal with this, right? Your users don't need to know what a conflict is in order to manually resolve one. So as an example, maybe you implement a pick a winner UI, where you have two competing pieces of data. But you frame it differently. You don't say, please resolve this conflict with Bob. Instead, you say, Bob made a different suggestion than you. And this hits a totally different note because people know what suggestions are, right? They know them from text editors. And they'd probably be more willing to deal with it because now it's become a human interaction and not a technological problem. And it's okay to fail if you fail usefully. And by fail, I mean fail to resolve all conflicts automatically. It's not your app's job to hide conflicts, right? It's to allow users to do work. And automated solutions cannot know the severity of a conflict, the context, or what the user's intentions were. And some things are just too complicated to resolve. Like at some point you have to say, look, all of you humans are obviously not aligned with one another. Why don't you have a meeting before you try entering data that you all can't agree on? Conflicts are not only technical issues, but can point to interpersonal disagreements and intra-organizational misalignments. Woo! How do I stop this? Thank you. Hiding these is counterproductive. You're just making things worse. So the value of your software is solving problems, not making more of them by making assumptions. Making conflict visible may be much more valuable than resolving it. So, in conclusion, sync engines. You're not just working on machine-to-machine communication, which is kind of what the title suggests. You're also working on human-machine interaction, because you're trying to communicate unfamiliar concepts. But most importantly, you're an intermediary in human-to-human communication, right? And that's the priority, and the rest is just a means to achieve that. All right, that's me. Thank you.